always possible to have the large data set. And another problem with the deep learning is that it requires the big computer. It requires basically the large memory based GPU, which is not very, which are not very economically viable. For example, when my student Manisha, when she had been going through this research, she asked me one day, sir, can we purchase that GPU? And I go, what does it cost? She asked me that, sir, it around 2 lakh something, 2 to 2.5 lakh. Remember, in an institute, see, you give the proposal for purchase it, and it takes time, and it is not easy to purchase for student wise. So remember, even in the Indian conditions, even it is not always feasible to have these deep learning resources. Deep mean where system is there. Even as I discussed with you that when I had been implementing that GSP paper. So when I was implementing that example, I asked that person, one of the author, sir, it requires basically 1,000 by 1,000 metrics. When I am computing it, my computer has become very slow. So is there any other alternative? You know what did he reply? He replied, no, you should have the good machine. In US, it is not a problem, but in India, it is not always easy to ask for those machines when you are working within some time constraint. So that's why I'm telling you, see, paper doesn't mean if somebody has written a paper or somebody has written a, somebody has conducted a research, it doesn't mean that they know all the answers. They know some of the answers. We must go through the complete research paper and we should implement it so that we see, we would have the different view. I'm telling you. So continuing with the part that unlike CNN-based model that require large data set, the proposed approach is designed to work with limited training images by leveraging machine learning tech. Machine learning doesn't require a large data set. Even if your images are in the 100, it would work. Apply page-based feature extraction and feature selection method to extract the robust feature from the face when occlusion present. Why do we somebody would be thinking why do we apply the patch paste? See, we apply the patch paste when there is a when we feel it that pixel based and for pixel based feature extraction takes lot of time, and sometimes the neighborhood information is important which is acquired with the help of the patch based unit. Occlusion segmentation with graph signal processing. Here see what do we do? Here we propose a graph cut method that extract occluded part while maintaining relationships between non-occluded and occluded regions. So, leveraging advanced graph signal processing techniques. What do you mean by advanced graph signals? The advanced graph signal is basically simply we are saying that the techniques which are basically extracting out the frequency-based component, graph Fourier transform, graph wavelet transform, to perform adaptive feature extraction from the non-occluded regions to enhance the model accuracy. Occlusion reconstruction method along with preserving identity. Here see in the first case we are taking the occluded as part of the image. In the second case we basically separate out the occluded part. In the third part we reconstructed that part along with preserving identity. So here what we are saying that proposes a computationally efficient reconstruction method that restores occluded facial regions. And unlike GAN-based generative adversarial network-based in painting method that introduce artifact, here it ensures structural coherence across facial features. So what is shown here? See, again, space recognition approach. It is theory approach. It is when occlusion is part of it. Here we occlusion is detected and we separate out it. Here we recover it, here by reconstruction. Whenever you are going to the works, so these are basically the handcraft features. In handcraft feature, for example, like the local binary patterns, it is there. What is the use of it? It is basically extract out texture-based descriptor. Texture-based means basically how much something is rough or is smooth. Weighted chi-square disturbance, scale invariant. See, whenever you are going, what is the use of the scale invariant feature transform? See, for example, when we see the very big size of the images, see, big and small size doesn't matter, but it is a key feature. What are those key features? That are invariant. Means even when you scale the image, even when you rotate the image, those points remain same. So that is all basically the same. Histogram of oriented gradients. Remember, what is the beauty of the histogram? It's a very simple concept. Very simple concept. So here actually the orientations are taken into account. What is on the x-axis? Orientation, oriented gradient. So that way we can. But Gabor filter is basically old approach. Here, why the Gabor filter is popular? Because it exactly resembles like the human eye filter, which we naturally use. Gabor phase feature. In Gabor phase feature, we basically use phase information instead of magnitude for better discriminability and recognition tasks. Local Gabor binary patterns. Here you combine Gabor transform, LVP, and local region histogram for robust feature extraction. Please remember key thing that whatever techniques are there, first you begin to apply it and then you do the experiment. Do the experiment, for example, applying first technique, then second technique. Remember, these experiments lead to the automatic, you say, automatic development of the intelligence. See, normally people say read more and more research paper, but I totally do not, I don't agree totally with that approach. It is your experiment. When you do small things and when you get the interest, that is the key thing. So what we are saying in the patch feature matching, in patch feature basically, instead of you take a patch, means which is a bigger in size, is square. Here you use a graph to represent a face where each node corresponds to a Gabor jet extracted from facial landmark. Difference of Gaussian operator. This is also very popular approach. Here you extract out the local descriptors. Each descriptor match within a spatial neighborhood, selecting the minimal distance. Random sampling patch-based method. You randomly sample the patches. Dynamic graph representation. Here you construct feature graph where each node represents a region of the face. And edge capture spatial relationships. There you use the graph-based representation. So here, limitation is there. So the subspace, it is another at space level. If you consider the technique, it is PCA, very popular principal component analysis. Here it is linear subspace learning, LDA, linear discriminant. Here it's a again linear subspace learning. So what is the difference between PCA? Here you represent the most representative subspace, while in the LDA you explore the discriminative subspace to differentiate individuals by incorporating class labels. Modular PCA. Modular PCA, what you say here, you build multiple eigenspaces in facial region to tolerate phase variance. Again, a region-based PCA, but little bit modification in PCA. Then robust subspace learning. Here you develop robust subspace learning using continuous optimization for linear model. Outlier detection PCA. Here we use the PCA to detect occlusions and calculate coefficients using the remaining pixels. Robust PCA filter. Here combine discriminative reconstructive properties to achieve good classification while detecting occlusions. All are basically the different variation of the PC, independent component analysis. Here you extract locally salient information from facial part for better recognition under occlusion. Kernel correlation feature analysis. Use kernel-based feature extraction of facial regions for partial face recognition. Confidence weighted subspace method. Here you weights basically image pixels based on confidence measure to reduce the effect of occluded pixels. So this is what about the statistical techniques? In statistical, it is a mixture of Gaussians for occlusion compensation. Here you use a probabilistic modeling by taking into account the Gaussian mixtures to handle occlusions. By here we select the largest matching areas and de-emphasize occluded regions with a low posterior probability. What is the limitation that occluded regions can always be identified through the low posterior probability? Self-organizing maps with soft KNN classifier. It is basically topology preserving subspace learning. Here you represent the face subspace using uh, self-organizing maps to map similarity relationship between subblocks and classify spaces with a soft K nearest neighbor ensemble classifier. What is required here? It assumes prior knowledge of occluded regions which may not be available in real world scenario. Local Gaussian kernel with SVM. Extract local features using Gaussian kernel function and trains an SVM by summing local kernel features. It is based upon kernel-based learning. What is its limitation? As it uses a fixed size local kernel, which is suboptimal, and it doesn't adapt to the different facial regions. Non-metric partial similarity measure captures prominent partial similarities in face images while excluding unreliable local features. But it is again based on the local similarity-based feature extraction. Statistical learning or local shift feature. Estimate the probability density of shift descriptors using a Gaussian model and applies a weighted distance measuring classification, probabilistic feature learning. General framework for statistical learning or local features. Here you extend statistical learning by integrating weighted local features and feature-based similarity for distance measurement. It is based on the weighted feature-based learning. What is the problem? That it can't encode spatial information of faces. Unreliable features from occluded areas reduce performance. See, what is the, you would be thinking that what is the use of these basically going through it. See, whenever if you have the chance to go through the face recognition, you take either of the technique and you just begin to, it is only a motivation. Those who are not doing it, so may you explore it, right? So don't definitely until and unless you will not implement it, you will not able to get the feel what we are saying. Sparse representation classifier. What do you mean by the sparse representation? It basically represents a test phase as a linear combination of training sample plus sparse errors to model occlusions. Sparse representation. See, what do you mean by the sparse representation? That where no more any dependency, no more any redundancy is there. What is the limitation? It's computationally expensive due to sparse coding optimization. So another technique basically on the representation is Gabor feature. Based robust representation and classification use Gabor features instead of pixel value to enhance identity discriminator and employs a compact Gabor occlusion dictionary for efficient occlusion coding. Those people who are seeing basically facial expression, facial recognition, they would be seeing basically a dictionary. When many things, when a law, a set of encoding techniques are used basically. So what do you mean by the sparse and dense hybrid representation framework? See, here it's basically both the things. Not only see it is redundancy, but also it covers also everything. So it introduces artificial occlusions in training data to enhance discriminative feature learning. Structured occlusion coding, it employs an occlusion appended in the last dictionary to separate occlusions from faces and classify them simultaneously. What we are doing, we are basically separating out the occlusions from the face. So Again, it is saying it is a dictionary-based occlusion separation, means it's again total set of the encoding techniques which are used. What is limitation? It requires corresponding parts of the dictionary, which may limit generalization to unseen occlusion. Efficient locality constrained occlusion coding. It reduces running time by estimating occlusions using identity unrelated samples. Topology to locality constrained sparse coding. It may slightly reduce accuracy compared to traditional SRC. Then thereafter, joint and collaborative representation with local adaptive convolution feature. Extract local high-level features from regular regions and enforces similar representation coefficients for local area. What is its topology? It is convolution-based representation. Another technique under the sparse representation, robust and discriminative low-rank representation. What does it do? It captures the global structure of the data and holistic structure of occlusion-induced errors for classification. See, whenever somebody is saying you something is local and global, how do you differentiate? See, if somebody say that I am interested in finding out local feature. Have you the idea? See, what is this local feature, global feature? See, very simple way to identify this thing. If you go through it, it is local feature. It is basically the small neighborhood is there, right? For example, the difference. For example, the edges, etc. When I am trying to find out the edges, vertical edges, horizontal edges, these are based upon the local features. What do you know the global features? The global feature means basically somebody responded. Global feature describe the entire image. Yes, see, absolutely. But how, the question, very important question is that how do you extract the global feature? What is global feature? Yeah, people very frequently use this word. So has anyone idea what is the global feature? Local feature is clear. Difference between small neighborhood, but what is the global feature? Provides context and overall image understanding. Yes, but question someone, what is global feature? Can you give example? See, I tell you, for example, when we are smiling, see, when we are smiling, see, what has happened that there is our eyes are also broadening, and our lips are also broadening. What we are seeing that there is a relationship between eye broadening as well as our lips broadening, right? So this is not something at the local level. Both these things at our eyes level and your lip level, both are basically interrelated. So this type of interrelationship is basically global feature. Means which is at somewhat higher level features, where some relationship is involved. So as soon as you identify the higher level features, once you are able to identify it, then it is far easy to capture the image. So whatever it is, geometric relationships between the two parts of the image, that one is also broadening, another is also broadening. So that is basically the global feature, right? So holistic, even what we say that the holistic view is given by this global feature. It depends upon the image, what objective you are doing. So in the keyword, it is basically the interrelationship based feature which are not directly visible, but which definitely helps to classify the image, identify the image. So our approach, whenever we want to recognize an image, our approach is basically to identify the local features, some local features and some global features. Because once you are able to capture out, then definitely whatever your objective is there, your accuracy will be very, very high. So one question is there to everyone, that whenever you identify the image, whenever you do any exercise, simply ask a question, can there be any global feature apart from the local feature? So centered, symmetric, local binary pattern. Remember, whenever you are talking about this LVP, etc., all are basically the local feature, NN, CS, LVP. So what you do here, it is texture-based sparse representation. Discriminative multi-scale sparse coding. What there, it's learns an auxiliary dictionary for occlusion variations using PC and apply the multi-scale error measurement to detect and exclude outlier pixels. Hierarchical sparse and low rank regression model. Use image gradient direction features for weak low rank optimization in occluded face recognition. So rank, etc. These are also the mathematical based features. It is almost somewhat higher global features. Nuclear norm-based adapted occlusion dictionary learning. It constructs occluded and non-occluded regions separately using training images to improve computing efficiency. Structural element feature extraction with adaptive fusion and fuse sort sparse representation learning. It captures local and contextual information inspired by the human optic nerve and applies fuse sort learning for occluded face recognition. Deep learning. What in the deep learning? Deep learning, if you see, it is you don't need to provide basically the any feature, they automatically learns it. But how do they learn it? When you train and train by the network, so whatever equations are there, they begin to predict. They begin to predict the solution, and so it is based upon basically training for. What is the problem here? It requires a massive data set with diverse occluded faces, which is difficult to collect. So it is not that easy from where you will collect it. Data augmentation with occluded faces. Here what we are saying that generates occluded face sample during training to make features extraction more local and robust. So data augmentation means basically we are also adding something. We are enhancing something with occluded. So topology, it is data augmentation for CNN training. Here CNN is not only for the classification, but also you can add on the data also. Synthesis of occluded faces with hairstyle and glasses. What do we do here? Collects and apply. What did in this paper 44, what has been done? It collects and applies 87 hairstyle templates and 100 glasses template to synthesize occluded face image for training CNN. What did they do? They basically synthesize occluded uh, facial image because they are using the CNN. What is the problem here? It is limited to handling sunglasses and ear occlusion. Does not generalize to all type of occlusion. See, whenever only you are doing the occlusion at the hair level, at the glass. Then the occlusion sensitivity based data augmentation. It identifies the high effect face regions and augments training data by applying occlusions more frequently to central face regions than outer regions. So what do you do here? Here, in which area? In central area, you are basically applying it. What is topology? Region sensitive training strategy. Predefined occlusions may degrade performance when dealing with occlusion or different sizes. So it is not always necessary that you sometimes occlusion of different sizes are there. So that's also we may have the large data set. Deep dictionary representation based classification. Here you use a dictionary to linearly code deep features extracted from CN. Dictionary means basically a set of features. Includes an auxiliary dictionary to model occlusion patterns in test phases. Deep feature representation with dictionary coding. What does it do? It assembles the occlusion patterns of test phases present in the auxiliary dictionary, limiting its generalization. So I didn't see occlusion detection based face recognition, partial face recognition. So what they are telling here that first they have detected occlusion, then they have detected the visible part, and then they have trained both the things. Partial face recognition, they are only using the partial face only without rejecting out the occluded part. So that is basically the occlusion detection face recognition. So what is in this work? See, one this neighborhood network threshold classifier. Here, patch-based occlusion detection is there. Feature selection from an occluded region. What is its what is its overall experience? That TCA subspace learning for occlusion-free patches. One NN classifier for occlusion detection, selective, local, non-negative matrix factorization for recognition. Performance here depends upon predefined occlusions struggles with arbitrary occlusion. What in the binary classifier approach, you use basically SVM classifier trained to detect occluded, non-occluded patches, exclusion of occluded regions before recognition. Phase divided into non-overlapping regions, binary classification per region. Highly sensitive to training, dataset, limited generalization for unknown occlusion. Local Gabor binary pattern histogram sequences. Here both the things are involved. Here feature-based recognition as well as the patch-wise occlusion detection. So in this technique, it is occlusion detection and segmentation module is there. Selective local Gabor binary pattern histogram sequences for feature extraction from non-occluded regions are used. Its accuracy depends upon the segmentation quality. It limited the robustness for complex occlusion. So compressed sensing approach. In this here comparison of occluded and occlusion free phases of same identity. One side occluded and another side it is occlusion free. Same identity, occlusion removal wise parts representation. As we have discussed in the last slide. Compressed sensing for occlusion detection. Feature exclusion for recognition. Requires pair occluded, unoccluded images. So computationally that is also expensive. Then it is the deep learning based occlusion detection. Here convolutional neural network is used for the occlusion detection, multitask learning for occlusion probability estimation of facial components. Here region specific occlusion detection is there. So for example, what are the regions where occlusion may be there in the face? It may be eye, nose, mouth. It is limited to predefined occlusion types. Remember, here we assume that your occlusion will be limited on this region, either in either of the region. But sometimes it is not necessary that it may be widespread, for example, through the eye, the nose also. Then it is not easy to perform with this technique. So there is also errors in detection of impact recognition performance. Visible part selection. What do you mean by the visible part selection? Visible part selection means, as we are saying that we use predefined facial subregions for recognition based on assumed occlusion. So here, feature-based recognition, manual subregion selection. It requires well-aligned facial subregions, poor generalizations in real-world scenarios with varied occlusion. Advanced occlusion estimation via NMF extends NMF with adaptive occlusion estimation based on reconstruction errors. Learns low dimensional representations to cluster features of the same class. So, what is here? In the topology, it is basically the feature learning, adaptive occlusion handling without prior knowledge. What is its limitation? Its performance depends on quality of reconstruction, it struggles with a complex occlusion pattern. Then comes the mask neck. Mask neck basically introduces mask net module in the middle layers of CNN to suppress occluded feature activation. CNN-based feature refinement. It is shallow convolutional network for occlusion aware representation learning. It requires training with diverse occlusion cases may still retain some occlusion related knowledge. Pairwise differential CME's network. It learns a mask to map occluded facial blocks to correct feature elements, reducing occlusion concept. So, what is here? It's sensitive to mask quality, may struggle with extreme occlusion. So, then thereafter, it is basically a feature extension is in PDSN. So, in the multi-scale double supervision convolutional neural network, here multiple CNNs are trained on the facial pitches of different scales. Multi-scale patches aligned based on eye corners. Final recognition accuracy is obtained by combining network height. Topology here is basically multi-network architecture, patch-based feature extraction. It requires training 55 different double supervision convolutional neural network, time consuming due to sliding window patch generation. You will find that these small concepts like the sliding window will allow you to implement those concepts in the reality. Comparison component ensemble of radial basis function network. So what we are doing uses an ensemble of 9 RBF classifiers with different cluster and overlay factor. Decision made based on RBF outputs. Here multiple classified system is there which is used on the voting based recognition. What is the problem? It is basically sensitive to clustering parameters. Here it is a low limited robustness to severe conclusions. Lophoscopic PCA. Lophoscopic PCA introduces mask covering different face regions to compute subspaces. Weights are learned for each space and combined for recognition. Subspace based face recognition as it is PCA, masked region while training. Recognition rate needs improvement, struggles with highly misaligned face. Multiple key point descriptor. Using multiple key point based descriptors for face representation. It's like the shift. Constructs a dictionary from large gallery images to sparsely represent partial faces. So here it is a sparse representation classification, patch-based recognition. It requires a large data set to cover all variations. It is computationally expensive. Occlusion aware face recognition. What do you mean occlusion aware? Occlusion aware means basically either I am extracting out that occluded portion, right? Either I'm extracting out that part. So what we are doing here, we use scale invariant feature transform descriptor. It measures similarity between probe patch and gallery images using a space constraint. Local descriptor matching, nearest neighbor research. So see here also you would see that people also wants to completely fill that exercise. But it fails when key points are missing due to occlusion sensitive to illumination change. Robust point set matching. What we are doing here it is a feature set matching and geometric textual consistency. So it matches feature sets based on geometric and textual similarities. Considers affine transformation. Constraints to avoid unrealistic face warping. Feature set matching, geometric, textural consistency. When does it fail? When face points are unavailable due to occlusions and it is also computationally expensive. Now come to the dynamic feature learning. Dynamic feature learning combines fully convolutional network with SRs. So uses sliding window matching for partial face recognition. Deep learning plus SRC hybrid plus window-based matching. Multi-scale dynamic feature learning. Extend dynamic feature learning by incorporating multi-scale representations, tolerate misalignment better. Deep learning with multi-scale recognition. Here also it is there. Here also improved alignment tolerance is there. But what is the disadvantage? That it is here increased model complexity requires extensive training data. Then we come to the sliding window matching, which has been popular in the started in the iteration. So it searches basically for the most familiar gallery patch using a sliding window approach. Here it is a window-based feature matching. It is SRCNN. It is computationally heavy and limited by the quality of gallery image. Now we come to the part, our last part where occlusion recovery is there. Face over face recognition. So how do you recover it? Sorry, it is in painting. It is non-blind in painting. It is deep learning for blind in painting. So reconstruction based face recognition. So what do you do? Here you do the linear reconstruction. Here you do the sparse representation classifier, or you can use the deep learning. But please keep in mind that here you are using deep learning for blind in painting. Here you are deep learning, or basically you have trained that data on your some model. So what we are saying here, it is basically linear construction. In linear construction, what we say that PCA reconstruction with recursive error compensation. It uses PCA based recognition and recursive error compensation to remove occlusions caused by glasses. Combines Markov random field model with a spot representation of better reconstruction. What is the problem? The limited specific occlusion types is struggle with larger data sets. So linear combination reconstruction, here you estimate the occluded test image as a linear combination of training samples across all classes, assigns different weights to facial areas to prioritize non-occluded region. As we told that we use the different weights. Again, here we are using to prioritize non-occluded region. Linear construction is the topology here, and the weighted region-based estimation is there. So linear combination reconstruction, what you do, it requires occlusions in both training and testing set, and it struggles with the extreme occlusion. Now SRC basically the sparse representation classifier. So here is it. Yes, so what do we do in the sparse representation classifier? It represents a test face as a sparse linear combination of training samples, sparse occlusion error, uses an identity matrix as an occlusion dictionary. It is basically the sparse representation classification linear occlusion modeling. So another sparse representation improved SRC with prior knowledge. How do you use the prior knowledge? Basically, you incorporate that prior knowledge of pixel error distribution. By taking that information, then you enhance the SRC. Sparse representation with error mode. What does it require? It requires accurate prior error distribution knowledge, which makes it computationally intensive. Graph-based phase completion. Remember, graph is present from a long time, but graph signal is basically a little bit new, almost 10 years before it has come. What do you know the graph? Graph is basically uses a graph model and an image-based data mining to find best matches for a phase synthesis. So phase completion is taken place via the graph Laplace transform. So what is graph-based occlusion? Repair uh, spot supplementation based matching. It depends upon high quality training images and struggles with highly distorted faces. So this way the downsampled SRC for occlusion detection and phase reconstruction. It uses downsampled SRC to detect occlusions, reconstructs an intact phase using an overdetermined equation system. It is low complexity SRC multi-stage occlusion handling. Down sampling may reduce facial detail limited to certain occlusion types. So here is a one question that when you are basically, I hope see everyone is aware, just a thing to bring you up. When we are saying see down sampling, see can you answer whether this down sampling is that the feature selection? Is it coming? Yes. Try to think about it. I just come in. Just return it 2 minutes. Try to think upon it when we are saying down sampling and feature selection. Are they same? Are they different?